Let's start with something scary. We're doing 7.6 Gaussian elimination. A guy named Frederick Gauss came up with it. This guy was like if I recall, Frederick Gauss was like a genius. He was doing proofs as a teenager, was writing major theorems at early 20, and I think he died because he just was walking around in the cold in a wet clothes and because he had a lecture to give. This guy, he was, I should quote, I think he was younger than 30 though when he passed, and he did more proofs than almost anyone else in all of mathematics. But anyway, I digress. Here's our goal today. We are going to take linear equations, systems of equations, and turn them into a matrix, and then use that matrix to find the solutions. Okay? So first things first, we need to be able to take a system of linear equations and turn it into a matrix. Okay. How do we do that? Well, make sure your x's are lined up, make sure your y's are lined up, and then make sure that's not x or y, okay? And now to convert it to a matrix, what we do is we take that and we just use our leading coefficients, and boom, that's a matrix. Okay? You use your leading coefficients and you just write them down. Okay? That's half the battle in order to solve this. Once you have it to a matrix, I'll show you how quick this can be. All right, what do I do if they are not x's and y's? Same thing though. You just make sure that all the rows are lined up. x1, x1, x2, x2. So to convert that to a matrix, that's a 1, -2, 10, 3, 5, 8. Okay. Any questions on that? If that was a test question, you would feel confident about it. All right. Uh-oh, what about this one? This one is an important one to talk about. All right. So when I turn this into a matrix, I'm going to have 1, 5, -9, -17, right? 1, 5, -9, -17. So this row is all my x1s. This is all my x2s. These are my x3s. And these are my constants, whatever they're equal to, right? So I have a 2 for x1. What do I have for x2 there, though? A 0. So you got to make sure to include that 0, okay? We got to make sure and include that 0. If you want to, some books will write a line here. You don't need to put that line there. It's just a way to visually represent that line. There's an equals on the other side, all right? Any questions on this, though? We are a third of the way through this lecture. So here's what we're going to do. So for Gaussian elimination, with a matrix, we can manipulate matrices however we want. Just like, I'm just going to show you a quick example. I posted a longer video on Moodle if you guys would like to watch how to do this the long way. It's about 15 minutes long. But just something I want you to think about. If I had a matrix like this, what it's saying I can do is I can swap these rows around. I can multiply this whole row by 4 and then add it to the other one. I can do, but that's what you guys did with elimination, right? With elimination, it doesn't matter which order you wrote the equations. No. With elimination, could I multiply something by it and then add it to another one? Yeah. It's just saying all those operations are possible. Now, what I'm going to focus on today is using a calculator to do this for us. Okay? That's going to be my big focus. The big focus today is going to be using a calculator. Desmos also has a calculator for this, along with that TI-84. Both work almost the exact same way. Okay, so if you go to desmos.com, it says matrix. They have a separate matrix calculator. But I want you guys to learn how to use the other calculator as well. So there's something called row reduced echelon form, RREF. Okay. What your goal is to get a matrix to RREF, reduced row echelon form, and that gives you the solutions. Your calculator has a button that does it. Okay. It has an RREF button. But basically, to be in reduced row echelon form, each leading row is 1. The pivot positions have zeros above and below. That means the leadings have above and below zeros. And it looks like a stair step. It's going to be better if I just show you what it looks like. This is what reduced row echelon form is. It leads with a 1. It leads with a 1. There's a 0 below the 1, a 0 above the 1. Okay? 1, 1, 1. Stairs going down. Zeros below, zeros above and below, zeros above and below the 1. Okay? I'll show you what this means when we actually solve them, but that's everything in matrices. Getting it to your matrix to look like that, you just solved it. You just solved the system of equations. These are also in reduced row echelon form. Leading 1, leading 1. It's still a staircase as long as those are zeros, right? As long as those are zeros. Leading 1 with a 0 below it, and that's okay that that's all zeros. Okay? As long as the next row below it, the 1 is to the right of it. Leading 1, and then zeros above and below the ones. And that's okay that the last row is all zeros, as long as it's stair stepping down and there's nothing in front of it as you go down. Okay? Trying to remember if there's a homework question asking you if it is in reduced row. Biggest thing I can tell you is if you get that question, is it in reduced row, look at these slides 8 and 9 and compare and see if it looks like those that are in reduced row. Or you can always ask. You guys don't have a lot of practice in matrices. I get that. These are not in reduced row. Here's why. Leading 1, this is not a 1, right? So if one of your leading numbers is not a 1, it's not reduced. Okay, it has to be all 1s. This one's not in reduced row because this is not a 0, right? Your 1s have to have zeros above and below them. Okay? And that's the 2 big things to look for a reduced row, besides the step down. All right? You guys got your calculators at the ready? Let's get to actually doing, why are we doing all this? To save us time, and time equals money. Could be day trading right now. All right. Oh, they're using these words again. What our goal is going to be is to force RREF onto these functions. We're going to force it. We're going to bend it to our will. We're going to force these matrices. We're going to defeat them. All right. All right, you guys got your calculators out? Again, watch the other video I posted if you like to learn to do this by hand. We are going to do this by calculator. So grab out your calculators. Follow along. We're going to do a bunch of these because I can show you how to do it. Are you okay, bud? All right. You guys got your calculators? Bless you. All right. We are going to step into, do you guys see, where's, oh my gosh. This button right here below math, you have to hit second matrix. Second matrix. And here's matrices. All right. That's fine. Actually, I can do this until for the peeps on the video. All right. So what we're going to do is we're going to edit edit the matrix. So we're going to go right to and hit edit. Uh-oh. Uh-oh. Stop it. Stop. I got to zoom out a little bit. Can you guys still see that? So hit enter on edit, and then we type in, you might already have a matrix in your calculator if someone else had used this at some time, but I don't know if this might be my first year teaching matrices, because it's, yep, just clear it. So how many rows do I have on this matrix? How many rows? 2. How many columns do I have? 3. Now, the good news is you know if you typed it in wrong because it won't look like your paper, right? It should be a 2 by 3 matrix. Wait, you guys can't see that calculator. All right, so go ahead and type in your matrix, your 2, -5, -28. Pew, 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 pew. Put your calculator down if you got entered in. That's your sign to me that you're ready to go. I just need signal so I know when I can go. All right. Now, I'm going to actually second quit and go back to the home screen. So second quit on your go ahead, you guys can do it. Second quit. Second quit. Now, how do we solve this piece? Get an RREF. I'm going to hit second matrix again. Everything we need is going to be in the matrix menu, this matrix menu. And then I'm going to go to math. And in math, I have all this different stuff I can do with the matrix. Okay? I'm going to scroll down until I see RREF, Reduced Row Echelon Form. I'm going to hit enter. So RREF. Oh. All right. Now what matrix I'm going to hit second matrix again. What matrix did I plug that beast into? Was it A? Yes. Well, I'm going to pause for a second.
What a sigma.
All right. So now what do? Drum roll, hit enter. Look at that. That's reduced row echelon form, right? Yes, sir. Yes, sir. Yes.
You think Mahomes knows how to do this?
No. So that's your reduced row echelon form. Oh, why am I? Oh no, have I been zoomed in this whole time?
You just zoomed it in.
All right. Let's do another one. Oopsie doodles. Sorry for the language. That's right. Yeah. All right, go ahead and try that one on your own on the calculator. Try that one on your own. All right. So hopefully if you did that, you got 1, 0, 2, 0, 1, -6. If you are in the internet world and you're having problems, there is another video posted, and we're going to do another one here in a second anyways. How do I get off this calculator now? Yep. All right. Someone asked, how would I do this one? It's the same way. What are your dimensions going to be, though, for your matrix? It's just going to be a 3 by 4, right? And then you plug it in, RREF. Everything's in that matrix menu. Just to think about it this way, I don't know, you use every top of that matrix menu, right? You're going to edit it, you're going to do the math part, and then you're going to do the names part, right? You're using all those headings to do this stuff. Edit your size of your matrix. Just over, yeah, you should be able to edit it and just type over top of this. So 3 by 4.
Very interesting.
What? Yeah, that's fine. Yeah. All right. No, you don't have to do this one. Here's what I would like to do. How do you solve linear equations? This is going to be the thing that's going to be money for you guys. How do you solve linear equations using a matrix? Now I'll say this. If you're given a story problem with two linear things with like percents, like amount of strawberry or dark chocolate or finance, could we use matrices to solve those now if we have this tool in our back pocket? Yeah, we can. So what's my first step to solve this thing? What do I have to have it in terms of first? I have to rewrite it as a matrix, right? So the first step is going to be to write this as a matrix. Step one. Then what are we going to do? We're going to RREF it. And then what are we going to do? Win. Now, that's it. It's going to be 2 steps to solve this. So go ahead, grab out your calculators, plug in that matrix, and let's reduce it. Give it a shot. I'm going to try as well. Let's see if I know how to do this. It's my first day. What if everything I taught you is wrong? You guys don't even know I make the keys. Yeah, basically. So 5, 10, 25, 7, 6, 3. Yep, get that type, get it reduced. See what it looks like. I will say this, if you are doing this, make sure you know how to do this on your calculator. If you can, if you're using Desmos to do these matrices, it's quicker. Because the matrix calculator, you don't have to go into menus all the time. Everything's right there. But I want to make sure you guys know how to use this. Second, matrix name. All right. So make sure you're getting this plugged in, getting the same reduced row echelon form. Yeah, but yeah. What was looking at? All right, let's go over this. So when you reduce row this beast, we got what? 1, 0, -3, 0, 1, 4, right? What does that even mean? This came from this equation, right? What this is actually telling me is 1x, you don't have to, well, plus 0y equals -3, right? So what's that telling me? X equals -3. This one's telling me 0x plus 1y equals 4. So what's y equal? 4. And that's a point. Don't forget that is a point. So xy. So did we solve that system of equations without doing any elimination, substitution, graphing? How long did it take us? Not very long, right? This is going to change your guys' life when you guys see systems of equations. Here's what I'd like you all to try. Try this beast. Let's try this beast. I'm skipping one. Will this work with a 3x4 matrix? Yeah. Did we already turn this into a matrix earlier in the notes? Yeah. So you guys go ahead and give it a try. I'm going to work on it as well. Give it a try. Give it a shot. Wee. What's that? I wish this monitor was a touchscreen. That'd be neato. Oopsie doodles. Biggest mistake made with these is make sure, just look at your matrix when you're done with it and make sure you plugged it in right, okay? Number one mistake is plugging in a number wrong, missing a negative sign, like careless little things like that. I didn't do it. Oh, I didn't do it yet. I'm slow. Slow is smooth and smooth is fast. Really? That's a Phil Dunphy quote. Maybe. All right. What do you guys get for your matrix? I got 1, 0, 0, negative 4, 0, 1, 0, 1, 0, 0, 1, 2. I'm going to pause for a second. Did we just solve a system of 3 variables? Yeah. What's x1 equal to? Negative 4. What's x2 equal to? 1. And what's x to the 3 equal to? 2. So this is why I said go back, and if you would like to do the 3 variable stuff with in 7172 with matrices, you can do the last 2 with matrices. Why not? Yep. Yep. Because remember, it's an augmented matrix, so think about like that's your line. So that goes along with your first variable, next variable. Boom, boom, boom. All right, I got one more really important thing to show you guys. All right, so by now we all agree that I can convert this into this matrix, right? Now I'm going to reduce row this, and I got 1, negative 3, 0, 0, 0, 1. Make sure you write this down. Now, that doesn't look like our other ones, right? 1, negative 3, 0, 0, 0, 1. What does this actually mean? So remember, matrices are used to represent real equations, okay? So what's our x equal to on this one? And what's our y equal to? I'm going to rewrite this back into this form. What this is telling me is x minus 3y equals 0. And 0 times x plus 0 times y equals 1, right? Because these are leading coefficients. A matrix is just a representation of linear equations for what we're doing here. So that's telling me 0 equals 1. Does 0 equal 1? Is that true or untrue? Remember, if you're solving equations and you get something that's not true, how many solutions do you have? None. There are no solutions. That's not that hard. All right, so here we go. No solutions. Remember, biggest thing is, if this is not true, if that's not true, it's no solutions, okay? If it's not true, does 0 equal 1? So look at your bottom row, if your bottom row is not true. Let's do this one. I changed it just a little bit. Look at that. I changed this equation just a little bit. Do you guys trust my ability to reduce row echelon form? When I reduce row this, I got 1, negative 3, 7, and 0, 0, 0. Now what that told me is x minus 3y equals 7, which it tells me 0 plus 0 plus 0, or I'm sorry, equals 0. Does 0 equal 0? And if that is true, it means there are infinite solutions. Yeah. It actually means any point on this line, because that's a line, like if I solve and get y equals, any point on that line is a solution. So there are infinite solutions. If this is true, it's infinite solutions for you. All right? And that's it.